Hi friends, you can see that I have gathered up three cell phones over here, and all these cell phones have many scientific sensors like accelerometer or gyrometer and magnetic compass. So over here I am trying to use a simple application. This is the frequency sound generator which generates sound, and according to the frequency which has been displayed over here, and if I switch it on, you can hear that there is a particular sound coming in accordance with this 271 hertz. So if I try and increase the level of the frequency over here, suppose, you can see that very high amount of sound is coming over here depending upon the 13,327 hertz. So higher the frequency, more is the pitch of the sound, and you can see the sound is very shrill in the case of this 13,327. So if I try and decrease it over here, you can find that the frequency is decreasing and the pitch also is decreasing. So if I try and reduce it in a considerable amount, you will find that the pitch over here is decreased in a drastic manner. Anyways, so what I am going to display over here is the system of beats. So just see that here there is 271 hertz and here there is 272 hertz. So we will try and hear the beats over here. So I'm switching it on, play. You can see one single sound coming, right? Now if I switch it off and switch this thing on, the 272 hertz is being heard. Now if I try and switch on both, you will hear the beats. The beat frequency depends upon the difference of the frequency between the two sound producers. Lesser the difference, more you will find the time period between the two beats, and the wavy form is very slow. Okay, now next what I try and do, I will try and increase this frequency. You can see that the beat frequency has increased. Now see, the beat frequency has rapid out more. It's quite quick. The main thing is that this sound is not produced by the cell phone. You will find that the sound is intensely produced by the single phone, and separately over here you will find that the and same over here also. If I try and switch this thing on over here, can you see the beat? This is 271 hertz and this is 273 hertz. So you can see that the sound is being heard. Now if I try and reduce it off to 272, see hear the sound. Let's increase. I am now making it 274. So it's 271 and 275. If I try and increase it to something 281, so the difference is 10 now. the sound is very rapid, the beat frequency. Human ear can distinguish up till 10 beats per second. After that it becomes intermingled. Same thing happens if I try and decrease it to, suppose, lower than 71, sorry, 271. See, same thing is being heard. This one is switched off. So 271 and 270. Okay. If I switch off this one, single sound, there is no wavy sound. Anyways, let's see if I decrease it. Okay, so why exactly this thing is happening? You must be knowing that two equations of wave that are superimposing, as y1 is equals to a sine omega 1t minus k1 x, and y2 is equals to a sine omega 2t minus k2 x, and when they interact with each other, then they form a particular beat equation that becomes a resultant wave, and that is quite very similar to 2a proportional to 2a cos omega 1 minus omega 2 divided by 2 and into t, and then other end it will have the sine function. So either way you will find that the beat frequency is accustomed accordingly. So the factor that omega 1 and omega 1 minus omega 2 is used inside the equation, that becomes the beat frequency. And also that you will have one more factor of omega 1 plus omega 2 divided by 2 inside that equation, that will become the formulation of the original wave that is incoming out. So one will have the amplitude factor, which will include the cos wave function, which will be omega 1 minus omega 2 divided by 2. So that will account for the beat frequency as an amplitude of the sound. So if I try and have this thing also switched on, you will find that the wave is changed a bit. And I'm making it 69, 71, 69 and 67. So let's switch off this one. You can see that the pattern of the beats changes with the three waves that is coming from the acoustics. Now three equations interact to form a different set of resultant. I am leaving up to the observer who is trying to observe this experiment that three waves interacts to form a different set of frequency of the beats. Well, quite different as compared to that of two waves. So I hope that you have enjoyed. Thank you so much, friends, for watching this video. Thank you.